Now in our next example, the mass of the block is 12 kilograms. It is moving at 20 centimeters per second. So the mass 12 kg is moving with speed of 20 centimeters per second, collides with an identical stationary block. Obviously, it will come to the rest. So if the coefficient of restitution is 3 over 5, what will be the loss in kinetic energy during collision? So in order to find the loss, we proceed as follows. Delta E, that is a small loss in energy, half M1 M2 over M1 plus M2 into 1 minus E square. This function we have derived earlier and it is multiplied by U1 minus U2 the whole square. Here M1 is given to us 12 kg, M2 that is 12 kg, masses are equal and E is 3 over 5. U1 is given 20 centimeters per second equivalent to 0.2 meters per second and U2 is equal to 0. Now on substituting the values, delta E is to be calculated. So we have taken delta E is equal to, and the values are being provided to us in the question. All values are just put in this expression and the final expression will become 7.7 into 10 to the power minus 2 joules. Now in our next question, a ball is dropped from a height h. When we say ball is dropped from height h, and masses m and g's acceleration due to gravity, obviously the potential energy at that height will be mgh. So whenever the height is h, its potential energy will be mgh. So our question is now, a ball is dropped from a height h on a stationary floor and rebounds several times until it stops. If the coefficient of restitution is E, then the total distance covered by the ball before it stops will be. Now, first of all, we take the height h1 up to which the ball rises. So, we will drop the ball, it will rise, and the height will be h1. After the first rebound is given as h1 is equal to, that will be E square h, that is square of the coefficient of restitution multiplied by height. Now, after second rebound, it will be h2 and that will be e to the power 4h. Then it will be e to the power 6 into h and so on. We will add it n times. So we have to use arithmetical progression or the mixed series. And S is found to be h plus 2h1 plus 2h2, that is plus up to 2hn. Similarly, all the three equations are mentioned and then we will calculate the number by using the geometrical progression, taking the radius of the second term or the distance between the second and the first term, that will be taken as, that is the geometrical progression. So h is 2h1 plus 2h2 plus 2h11 plus and so on. H plus 2e square h plus 2e to the power 4h plus 2e to the power 2h into h. Now, we have to use a formula that is where sum to n terms of this series or up to infinity will be a over 1 minus r, where r is greater than 1. So, s is equal to h plus 2e square h over 1 minus e square, and that is equal to 1 plus e square over 1 minus e square multiplied by h. So here the formula is mentioned, that is sum to infinity of a geometric series, that will be a over 1 minus r, where a is the first term and r is the common ratio. Common ratio means r will be taken as the second term divided by first term. So if r will become less than 1, the formula is, in the denominator it should be 1 minus r, but if r is greater than 1, the formula should be written as a over r minus 1. Now we come to another example, a bullet of mass 10 grams traveling horizontally. So it is moving in a horizontal plane and the velocity of projection is 300 meters per second, striking a block made up of wood, and the mass of wooden block is 290 grams. which rests on the rough horizontal floor. After impact, the block and the bullet move together and come to rest. When the block has traveled a distance of 15 meters, the coefficient of friction between the block and the floor will be how much? Duration of impact is very short. So to solve this question, we first of all take the mass of the block and the bullet. So that is m and m respectively. If v is the velocity of bullet and capital V is the velocity of block, with bullet embedded in it, means it will penetrate in it. Now, according to the conservation of momentum, mv must be equal to total mass multiplied by total velocity. So, mv is equal to m plus m multiplied v. Now, we compute the values which is given to us in the question, and after calculations, we will get v, that is 10 meters per second. The kinetic energy just after impact, that is after collision, is half mv square. So we have written half of, and then it is m plus m into v square, which is lost due to work done on it by the force of friction. Since the force of friction is mu into m plus m into g, and the work done is given by F into d, that is force into displacement. So this fact is to be applied, and to get the value of m, the formula will become half of 10 divided by 10 into 15 equal to 1 over 3. Now we come to the next note. An external horizontal force due to friction is present. However, as it has been assumed that impact lasted for a very small interval of time. So if the impact lasted for a small time, impulse will be taken as force multiplied by time, and its unit will be Newton's second. Now, the block could not move appreciably. No work was done by friction during impact. Here, during impact, the presence of the function cannot be ignored.